Hi, and welcome to this section of the Chemistry Tutor. And in this section, we're going to conquer the very important topic of atomic mass of an element. Now, we have kind of danced around this a little bit up till now in this course. We've discussed, in general, the elements in the periodic table. We've talked about the isotopes, the number of protons, neutrons, and so we all know that these elements have mass. We all know that some elements are more massive than other elements, and I've kind of hinted that as you go farther and farther in the periodic table to higher and higher and larger atoms with more protons and more neutrons, then those atoms are more massive than, the lightest of the elements, which would be hydrogen. Helium would be the next least massive element that we have. So those are very low mass gases, basically. But as you go down the periodic table, you get to heavier and heavier elements. And so we've also talked conceptually about the relative mass of protons and neutrons, and we kind of talked about the fact that you can kind of count the protons and the neutrons in the atoms and kind of get a rough estimate of what its relative mass is. And we talked about that we could assign a proton a relative mass of 1. Instead of talking about how many grams it has, we just say that it has a mass of 1. And so you can definitely get a good feel for how massive an element is just by counting up its protons and its neutrons, because those are the two things that are going to basically determine the mass of the atom. The electrons have so little mass that they really don't contribute much. Well, here you might wonder, why are we talking about atomic mass? We've already covered that. Well, see, the thing is that we've actually covered some topics in between then and now that kind of are going to lead us down this path. So what I want to do first is have us recall a few facts that I hope you remember, and we're going to refresh them here. And then I'm going to present sort of a definition of atomic mass that I think is going to make a whole lot of sense once we review where we've been. So let's do that right now. So we'll do a little bit of review briefly. So recall. And the only reason I'm doing this here is because it's going to tie directly into the topic. Okay, so some things that we've already learned in previous sections. Every element, this is sort of to set the stage. Every element has a unique number of protons. So what this means is that all samples of hydrogen are going to have 1 proton. All samples of helium are going to have 2 protons. All samples of carbon are going to have 6 protons. And so that's the atomic number that we've talked about on the periodic table. No matter about the isotopes or anything else, the element is defined by how many protons we have. So that's sort of a fact. So keep that in the back of your mind. Second thing, let me go ahead and switch colors here really quickly. The second thing that I want to recall, we'll talk about isotopes, since we've already discussed that recently. Isotopes of the same element have different number of neutrons. All right, this should not be a surprise. This is the definition, this should not be surprising. This is the actual definition of what an isotope is. An isotope is when we have an atom which has, let's say carbon has 6 protons and 6 neutrons. If we stick an extra neutron in there, it's still carbon because it has 6 protons, but it's just heavier because it has an extra neutron. So that's the definition of an isotope. Isotopes of the same element have different number of neutrons, but they're always going to have the